This time, we're going to discuss about the system of linear inequalities. Two or more linear inequalities considered together form a system of a linear inequalities. So, the example that we have, x plus 2y less than negative 4 and 3x minus y less than negative 3 are example of a system of linear inequalities. A graph of an inequality in two variables x and y consists of all points xy whose coordinates satisfy the inequality. So, in a system of linear inequalities, we do apply the same with the linear inequality in two variables. So, first thing we have to do the first linear inequality, which is x plus 2y less than negative 4. So, the best solution is to use the intercept method. So we have x plus 2y less than negative 4. So in the intercept method, we identify the x-intercept wherein y is 0. So, we can use a short technique in answering this. So, we can find x-intercept by covering the y since that is set to be 0. So, when we cover this, we have x is equal to negative 4. So, our x-intercept is negative 4. How about the y-intercept? So in the y-intercept, we set x as 0. So we cover the x variable because that is considered 0. So that will become 2y is equal to negative 4. So, divided both sides by 2 to get y only. So, 2y divided by 2 is y. Negative 4 divided by 2 is negative 2. So, this time, our y-intercept is 0, negative 2. That is for the first inequality. So, let's go with the second inequality. 3x minus y is less than negative 3. So, the same procedure to find the x-intercept. So, we cover the we cover the y. So, 3x will be, 3x is equal to negative 3. Divided by both sides by 3, so that is 3x divided by 3 is x. Negative 3 divided by 3 is negative 1. And then for the y-intercept, so we set x as 0 and then we have y. So we set this x is 0, so negative y is equal to negative 3 dividing both sides by negative 1, that will be negative y over negative 1, that will be y, and negative 3 divided by negative 1, that will be positive 3. So our y-intercept is 0, 3. This time we have already 2 points for x plus y less than negative 4 for the first inequality, and then we have negative 1, 0, 0, 3 for the second inequality. This time we're going to graph this. Since we already identify the value that we have to locate on the Cartesian plane. So let's draw now a Cartesian plane. So the vertical line is called the y-axis, and then the horizontal line is called the x-axis. So for the x-axis, we have -4 and -1. So 1, 2, 3, 4. So -1, -2, -3, and -4. And this time we have 1, 2, 3. Positive 1, 2, and 3. Then for the vertical axis, so we have -2 and 3. 1, 2, 3. 1, 2, 3. Then we can include 4. 1, 2, 3. So we have -1, -2, -3. Okay, so we have to plot one by one. So let's plot first for the x plus 2y less than -4. So this is -4, 0. So it will be on the left side of the x-axis. 4 units from the origin going to the left. So that is -4, 0. Then we have 0, -2. So from the origin going down, so -2. So that is 0, -2. So now we're going to connect the points. Okay, so since this is less than, we use a broken line for the boundary line. So broken line. So always use a straight edge to connect and to draw lines. So that is x plus 2y. We can write this as x plus 2y less than -4. Okay, so we're going to have a test point here. So for the test point, we will use 0, 0. So if we make this 0 and y is also 0, the x is 0 and the y is also 0, this will give you 0. So 0 is less than -4. That is false. Again, the test point is 0, 0. So we make x as 0 and y as 0. So 0 plus 2 times 0 is 0. Is 0 less than -4? So the answer is false. That false indicates that 0, 0 here is not the solution. So with the boundary line, we shade the lower or the below part of the boundary line because this is the solution. So you have to shade. You can use crayon. Included. Okay, so that is the solution of x plus 2y less than -4. So let's proceed now with 3x minus y less than -3. So we'll locate -1, 0. So it would be here. So that is -1, 0, and then we have 0, 3. So this will be 0, 3, 0, 3. And then we connect the points. Okay, before we connect the points, this is less than also, so we're going to use a broken line, broken boundary line. So connect it, extend, always extend your line. Okay, so extend it. So this will be the boundary line for 3x minus y less than negative 3. So this time we're going to use again the test point of 0, 0. So 3 times 0 is 0, minus 0 is 0. Is 0 less than negative 3? That is false. So again, 3 times 0 is 0, minus 0 is 0. Is 0 less than negative 3? So that is false. So if that is false, it means the solution set will be on the upper or above the boundary line. So we draw here. Okay. So in the system of a linear inequalities, you have noticed that there is double shaded here, this part. So this part indicates that this is the solution of the system of linear inequalities. So by graphing, you have to show that there is a double shaded, the overlapping part. Okay, so we're going to get 1 point, 1 ordered pair in this shaded region. So I may use negative 5, 0. So let's try this. So check negative 5, 0. If negative 5, 0 will be true on both linear inequality. So we have x plus 2y less than negative 4. So negative 5 we substitute, plus 2 times 0 less than negative 4. So negative 5 plus 2 times 0 is 0. So this will give you negative 5 is less than negative 4. So is negative 5 less than negative 4? True. So it means negative 5, 0, which is here, is a solution of x plus 2y less than negative 4. This time we have to check it also with the second inequality. So we have 3x minus y less than negative 3. So we have to check this whether this negative 5, 0 is true with the second inequality. So we have 3 times negative 5 minus 0 is less than negative 3. So 3 times negative 5 is negative 15 minus 0. That will give you a negative 15 less than negative 3. Is negative 15 less than negative 3? True. So it means that the system of a linear inequality x plus 2y less than negative 4 and 3x minus y less than negative 3 is true on negative 5, 0. So, by graphing, you can show that there is a double shaded region. And by solving, getting one of the point from the shaded region, by solving, we conclude that both inequality are true. Okay, so we have checked that 0, 0 is not true, so it's false. So this is the system of linear inequality. So let's have a second example. For the second example, okay, let's move with the second example. Graph of the system of linear inequalities. This time, I have x plus y less than or equal to 4 and x minus y greater than 1. So you have noticed that the inequality symbol of this given are different. Okay, so let's find the intercept of the first inequality. So x plus y is less than or equal to 4. So A, which is the x-intercept, is equal to, when we set this with 0, that will give you a 4. So that is 4, 0. And B is for the y-intercept. So we set x as 0, then that will give you 4. So this is already the ordered pair of x plus y less than or equal to 4. So let's have x minus y greater than 1. So our A will become, that will be covered, and that will be 0. So x is equal to 1. And then for the y-intercept, so 0 is the x. We cover this, so that is negative y less than 1. So that is negative. We divide it both sides by negative 1. So that will give you negative y over negative 1 is y. And 1 over negative 1 is negative 1. Okay, so we have already the 2 points. Now we have already 2 points. This time we're going to graph this now. Okay, let's draw a partition plane. So we have 4, 4 on x and the y. So let's draw partition plane. So y, and then we have 1, 1 on 4, 4, then 1, 1. So go past 4, 1, 2, 3, 4, 1, 2, then we have 1, 2, 3, 4, and 1, 2. So we have positive here. So please always label your partition plane. Okay, now we're going to plot 4, 4, 0. So 4, 0 is here. So that is 4, 0. And then we have 0, 4. So 0, 4 is here. So 0. Then we connect the points. Okay, before we connect the points, we check that this is less than or equal. So we have to use a solid line. Solid line, straight. Okay. So this is, you can write here, x plus y is less than or equal to 4. So that is the boundary line for x plus y is less than -4. So we use 0, 0 as a test point. So 0, x plus y less than or equal to 4. So we set x as 0 and y as 0. So 0 plus 0 is 0. Is 0 less than or equal 4? That is true. So it means the shaded part will be below the boundary line. So 0, 0, 0 is a solution. Okay, so we shade this. 0, 0 is included. So all, we can extend it. Okay, now let's have the x minus y less than 1. So we plot 1, 0. So 1, 0 is here. 1, 0. And then we have 0, negative 1. It's here. 0, negative 1. And then we connect. So what boundary line we're going to use? We use broken, because this is only greater than. So we connect and we use broken lines. So broken. So extend your lines, draw a double arrow on both sides. Okay, our testing point is 0, 0. So if x is 0, minus 0 is 0. So is 0 greater than 1? That is false. So if that is false, if this is our boundary line, so we shade below. Because 0, 0 is here, it's not included. It's false. 0 is not greater than 1. So we will shade below. So we shade. We shade. Shade. Okay. So this is the graph of the system of linear inequality of x plus y less than or equal to 4 and x minus y greater than 1. So this part, the double shaded, this part is the solution. So we all know that 0, 0 is true in x plus y less than or equal to 4. So we check any point here as a test point. So we can use 3, 1 because it's still here. So let's try 3, 1. So 3, 1. Let's try 3, 1. Okay, so check 3, 1. If this is true on both inequalities. So we have x plus y less than or equal to 4. So that is 3 plus 1 less than or equal to 4. So 3 plus 1 is 4. Is 4 less than or equal to 4? This is true. because the inequality says less than or equal. So equal is included, so that is true. How about on the x minus y greater than 1? So we have 3 minus 1 is greater than 1. So what is 3 minus 1? That is 2. So is 2 greater than 1? And that's also true. So this is how to graph and to check the system of linear inequality in two variables. I hope this helped you. Thank you.